Alright, welcome to a video on section 4.8, which is looking at applications of trigonometry. Okay, so to begin with, we're going to look at angles of elevation and angles of depression. So an angle of elevation is pretty much you have a horizontal line and you're looking up. So you're looking like the guy on the boat is looking up to the guy on the lighthouse. So just think of it as you're looking up. All right, if it's an angle of depression, you have a horizontal and you're looking down. So think of it as like the guy on the lighthouse is looking down towards the guy looking at the boat. Okay? All right, so let's do an example here. Okay, so the angle of depression of a buoy from the top of the Barnegat Bay Lighthouse is 130 feet above the surface of the water. 130 feet above the surface of the water is 6 degrees. Okay, so we're going to draw a lighthouse. Okay, here's our lighthouse. All right, it's on the top of the bay or something. We've got our water. We have our buoy, and the buoy is one of those things that just floats. I don't know what it looks like. There's my buoy. Okay, so let's label the information that we're given in the picture. So they tell us that the angle of elevation, actually this makes it look like it's much bigger than it, or closer than it really is. It's probably very tiny. Okay, there it is. All right, so it's the lighthouse, they tell us, is 130 feet above the surface of the water. Okay, and the angle of depression. So angle of depression means we have a horizontal going this way, and we're looking down at the buoy with an angle of 6 degrees. Okay, now what you need to remember about this is that, well, there's alternate interior angles going on here. So if this angle right here is 6 degrees, so is this angle. They will also be 6 degrees. Okay. Find the distance x from the base of the lighthouse to the buoy. So this is what we're looking for. And we can assume that we have a height here, so we have a right angle. So this is basic trigonometry, something you could have done in geometry or math too. Okay, so when we are setting it up, we want to decide, are we using sine, cosine, or tangent? Okay, we are using this side. That side, of course, is the adjacent side. Okay, and we are using this side, which is the height, and that is going to be your opposite side. So adjacent and opposite means we are going to be using tangent. So we set it up. The tangent of 6 degrees is equal to the opposite, 130, over the adjacent x. All right, so we have an x in the denominator. I'm going to multiply both sides by x. And then I'm going to get x times the tangent of 6 is equal to 130. Divide both sides by the tangent of 6. And we get x is equal to 130 divided by the tangent of 6. Punch that into your calculator, and we get that x is approximately 123 or 1,236.9 feet. If that seems like a really big number, it's in the thousands. 6 degrees is like super skinny. Okay? And so if this is 130, maybe that'll give you a better accurate understanding of why this is like nearly 10 times the length. Okay, let's look at a couple more examples. These ones are a little less straightforward than that one. All right, from the top of the 100-foot Altgelt Hall, I don't know how to pronounce any of these names today, a man observes a car moving towards the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? So even though these cars are different colors, they are the same car. They're using different colors to set, so you know that they're different in some way, and that's just in time. Okay, so we have an angle of depression of 22 and 46. Okay, so let's look at each one here. For the 22 degrees, it's going to be the first time he looks at the car. This is 22 degrees, which means that by alternate interior angles, this is 22 degrees. Okay, and then he looks again. Sorry, this line right here would be 46 degrees to this line. And so you do alternate interior angles, and this would be 46 degrees. So the question is looking for the distance x that the car travels between these two spots. And they also tell us one more piece. They tell us that the height of the building is 100 feet. Okay, so if we separate this, you should see that there are two right triangles involved here. There is this one. Okay, that one is fairly simple, and that's going to help us find D. Okay, we got 46 degrees, got a right angle, we got 100, we got D. We'll come back to that. And so then we have this one. Okay, the one that's a bit larger. All right, this is also 100. This is 22. And then this is x plus d, right? It's this whole distance right here. Okay, so we need to find x, but in order to find x, we need to find d. So that's where we're going to start. We can write two equations here. Both of these are going to be using tangent. We have opposite and adjacent. So this one would be the tangent of 46 is equal to 100 over d. Okay, this one is going to be the tangent of 22 equals 100 over x plus d. Okay, let's solve for d here. Okay, just like in the last problem, whenever you have x in the denominator, you always end up dividing. And so that could be a shortcut that can help save us some time. D is in the denominator. Basically, when I do this, you've seen this enough by now, I just swap these. I think of it like over 1. And I'm going to get D is equal to 100 over the tangent of 46. Okay. All right. So we could do that same idea over here. We can get x plus d is equal to 100 over the tangent of 22. Okay. So putting it all together, we know the whole distance is 100 over the tangent to 22. And we know this distance is 100 over the tangent of 46. Okay. So if we want to find x, we just need to subtract them. So x is the 100 is the whole thing, which is 100 over the tangent of 22, minus the d, which is 100 over the tangent of 46. Okay. Yes, you could have found d and got a decimal, and you could have found the whole thing and got a decimal. I'm just going to do it all in a calculator. If you do it all in the calculator once, you're going to have less rounding issues. Okay, so in a calculator, plug all that in, and we're going to get 150.9 feet. Okay, next we're going to look at the penguin problem. Okay, The penguin is actually a helium-filled balloon. So a large helium-filled penguin is moored at the beginning of a parade route, awaiting the start of a parade. Two cables attached to the underside of the penguin make the angles 48 degrees and 40 degrees. Okay, so this one is going to be the 48 degrees, the bigger one. And then the smaller one is 40 degrees. Okay, so these are the two cables. They also tell us that the cables are attached to the ground 10 feet away from each other. That's this 10 feet. So that's the distance between these two cables. The question is, how high above the ground is the penguin? So this height is what we're looking for. Okay? Okay, so let's again use two triangles. So we have this triangle. And we're going to add in another variable here to help us solve this. So we're going to add in this distance, which is x, so that the whole distance here is going to be 10 plus x. Okay, so for the green triangle, the tangent of 48 degrees is equal to the height over x. Okay, that's our green one right there. All right, we'll do a blue one. The blue one is the whole thing. We're going to get the tangent of 40 degrees is equal to the height over 10 plus x. Okay? And our goal is to find h. So this is kind of like a system with trigonometry. So what I'm going to do is I'm going to solve both of these equations for h. So just multiply both sides by x. So here I get h is equal to x times the tangent of 48, or the tangent of 48 times x. Here I'm going to multiply both sides by 10 plus x. Okay, and I'm going to get h is equal to the tangent of 40 times 10 plus x, or the 10 plus x times, it doesn't matter, the order can swap. Okay, we're just multiplying. All right, and since we're doing a system, we're solving for h. Both of these are equal to h, so I'm going to set them equal to each other. So actually I'm going to write this as the tangent of 48 times x, switching it around, is equal to the tangent of 40 times 10 plus x. So I want to solve for x here. Now this looks a little crazy, but I just want you to remember that the tangent of 48 and the tangent of 40 are numbers. I don't want to figure out what those numbers are though. They're just coefficients and stuff. Okay, so I'm going to distribute the tangent of 40. So I get 10 times the tangent of 40 plus the tangent of 40 times x equals to the tangent of 48 times x. Okay, I need to get my x's onto the same side, so I'm going to subtract the tangent of 40 times x from both sides. Okay, now that's gone. Now, it would be so lovely if I could subtract 48 and 40 and get the tangent of 8 of x. And that does not how it works, unfortunately. All right, so the way that I'm going to write this is I'm going to write the tangent of 48 minus the tangent of 40x equals 10 times the tangent of 40. Okay, almost there. To get x alone, I'm going to divide both sides by this big old ugly thing. Specifically, the tangent of 48 minus the tangent of 40. All right, that is x. Okay, so you're going to have to do some careful calculation. We're going to do a little calculation here. There might be an easier way to do this problem. Feel free to let me know what you think might be the easier way. I'm solving for x and then I'm going to find h. Okay. The solution for x is about 30.4. Okay, but what I suggest you do is find this in your calculator, leave it in your calculator, don't actually round it and delete it from your calculator, just leave it in your calculator, okay? Okay, because to get h, remember, once we have x, just multiply it times the tangent of 48. So I suppose what you could do is just multiply this by another tangent of 48, and then this is your h. Okay, because if you look right here, if we substitute the x, we just got to multiply by the tangent of 48. All right, so you go ahead and do that, and you should get 34.3 feet in the air. Okay, next type of problem we're going to look at is navigation. All right. Okay. So there's a couple things going on here. We need to understand what bearing means, and we need to talk about knots. Okay, so a U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 knots or nautical miles per hour, traveling 2 hours on a course of 53 degrees, and then 3 hours on a course of 143 degrees. Okay, so nautical miles per hour is just a speed. And so we're going to need to get distances from those speeds. Also, in this picture here, Port Cleveland is A. Okay, that's where we're starting at. Okay, and so we end up traveling to B, which is our first set of our course. Okay, so it's traveling for 2 hours at 35 knots. So one old school formula that we need to remember is distance equals rate times time. So there's a distance here. This distance is going to be, so this distance right here is going to be the speed rate times the time. So that distance, I'll call it D1, is the rate of 35 nautical miles per hour, 35 knots, times 2 hours, which is 70 miles. So this is 70 miles. Okay, so then we're going to do that again for the next course. Don't worry about the degrees right now. So then we go 3 hours on a course of 143 degrees. So it's still 35 knots. Call this, so we're talking about this distance right here. Oops, wrong color. We're talking about this distance right here. Okay, so I'll call that like D2. So that's 35 knots at 3 hours, which is 105 miles. So this is 105 miles. Okay, so what that gives you is the legs of a right triangle. But if you're wondering, like, how is this a right triangle? Let's talk about those angles now, the bearing. Okay, the bearing depends on where north is. So it tells us north is going that way. So if north is going this way, the bearing is 53 degrees in our first course. We're going 53 degrees from north. Then we're going 143 degrees from north. Okay, so there's a bit of geometry going on here. We've got alternate interior angles here. So if this angle is 53, beta, what this is beta is 53. Okay, so this is 53. And then alpha right there, so alpha, this thing right here, that is, you could see supplementary to the 143. So if you do 180 minus 143, you are going to get 37 degrees. So this one right here is 37. If you take 53 and 37 and add it up, you get 90. Okay, so we have a right triangle. Okay, so then the question is, we have two parts to the question. What is the boat's bearing? How many degrees from north? And what is its distance? Okay, this distance is easy. Just Pythagorean theorem, right? So we got 70 squared plus 105 squared equals that distance squared. Call it d. All right, that's old school, okay? Square it, add it, take the square root, we get the distance. The distance is about 126.2 miles, okay? All right, so now we have to find the bearing, okay? The bearing is this theta right here. I'm running out of colors here. All right, we need to figure out that theta. So we need to use inverse trigonometry to find that angle. Well, the bearing actually isn't not the entire angle theta. It's to the straight up and down line that represents north. So what we need to do is we need to figure out 53 plus theta. And so we have to find theta and then add 53. So in a right triangle here, we can use theta. We can find theta by using tangent. We have the opposite and the adjacent, or sorry, this is the opposite, this is the adjacent of that angle in the right triangle. Let's redraw this triangle a little bit. It's a little crazy. Okay, we have, this is theta, this is 70, this is 105. This is due north, so this is 53. So if we found theta, we can add it to the 53. Okay, so we're going to do tangent of theta equals the opposite, 105 over 70. So to solve that, we're going to do tangent inverse of 105 over 70. Push the buttons in the calculator, and we get that this is approximately 56 degrees, but then the bearing is 56 degrees plus theta, sorry, 53 degrees, which was this one over here, plus the theta, so 53 plus 56 is 109 degrees from due north. Okay, this video is getting kind of long, so I'm going to do a part 2 for the last two problems.